Hello everyone, I welcome all of you to this lecture. Let us start today's lecture with a new point, that is performance characteristics. So before starting this new point, please go through all the points that we have seen earlier. Just have a look on that. Previously we have started with different types of standards, that is international standards, primary standards, secondary standards, then working standards. So after that we have seen the basic difference between this international standard, primary standards, then secondary standards, and then working standards. Okay, so after that we have started with measuring instrumentation types or instrument types, and we have seen the brief introduction about this different types of measuring instruments. Okay, so this all classification we have covered, and right now we have to start with performance characteristics of any measuring instrument. Okay, now instruments are very important parameter in measurement and instrumentation field or industry, because whatever the instrument that you are using, the first thing is that it must be standard, okay, or it must be designed with considering standards, international standards. It may be primary standards, secondary standards. Okay, and after that we must know the performance of that particular instrument. Okay, so we have to analyze the performance of that instrument. Okay, and that performance is nothing but a performance characteristics. Okay, now if you categorize this performance of this instrument or performance characteristics of instruments, so it may be static or it may be dynamic. Okay, so if you see the static characteristics, there are n number of parameters available under this. Okay, and there are less number of parameters available under the dynamic characteristics, but these two are very important, which are to be considered while evaluating the performance of any instrument. Okay, so before using, you must know the static and dynamic characteristics of the instrument that you are going to be used in your actual system or industry or your application. Okay, so let us start with this. Okay, so here if you say the one thing is mentioned is that for selecting an instrument in order to achieve some desired function or application, we must know the performance of a instrument or the performance characteristics of an instrument that we have discussed earlier, and it is divided into two types. So it can be static characteristic or it can be a dynamic characteristic. Okay, now let us start with the first type, that is a static characteristics. Okay, so what is the basic difference between the static and dynamic characteristics? Let's start with the static. What do you mean by static first? I think you may have used this word static and dynamic in electronic circuits. You must know which components are static and which components are dynamic in behavior, because they are very important for analyzing any circuit's behavior. Okay, so for example, if you see the capacitor and inductor, they are generally dynamic in nature, means they are energy storing elements, and at any time we must know their behavior, the dynamic behavior. On the other hand, if you see the resistor, it is not storing any energy, it is just opposing the current. It can be called a static component, and you can easily analyze the resistive circuit, but it is more complex to analyze the dynamic circuit which uses capacitor and inductor. Okay, so just like this, there are different characteristics based upon this same definition of static and dynamic. Okay, so what do you mean by static here? The static characteristics are defined for the instrument which measure quantities which do not vary with time. Okay, so which are fixed generally and do not vary with time. Such a parameters or qualities can be called as static qualities, and the characteristics of that parameters is called as static characteristics. Okay, so let's start with the classification of this static characteristics. See, there are n number of parameters available under the static characteristics. So the most important things are the accuracy, precision, and sensitivity, as well as resolution. and all other parameters are also available here, okay, that we have to study. So we have to start with accuracy, then precision is also important. We have to see sensitivity, then resolution, then threshold, drift, error, repeatability, reproducibility, then readability is also there, okay, which is not included in this, but readability we have to also see that. Okay, after that we have to see the dead zone, backlash, true value, hysteresis, linearity, range or span, then bias, then tolerance, then stability. These are n number of static characteristics are available, and we have to cover most of this, okay, so don't worry about that. We will start with the first and most important static characteristics of any instrument, that is accuracy, which is very important as far as the application or the instrument is concerned, okay. So that's why the accuracy is very important, which is our first choice or first option while selecting any instrument for the measurement, okay. So what is the accuracy basically? So it is a degree of closeness with which an instrument reading approaches the true value of the quantity being measured, okay. So it is just a degree of closeness. So if the degree of closeness is high, then we can say that accuracy is very high. If degree of closeness is less, then we can say that accuracy is less, okay. So this degree of closeness to the actual or true value of the quantity to be measured is nothing but your accuracy, okay. So the accuracy of the instrument indicates the nearness to the actual or true value of the quantity, okay. So that's why accuracy is very important. So generally accuracy, if you see the accuracy, the extent to which a measured value agrees with a true value, okay. And the difference between the measured value and the true value is known as error of the measurement, okay. So generally this accuracy gives you the error, definition of error, and we have to see the classification of errors that we are getting while the measurements is done, okay. So that we have to see separately, but the difference between the measured value and the true value can be called as error of measurement, and whenever this error of measurement is very less, then we can say the accuracy is very high, okay. So the extent to which the measured value agrees to the true value is also called as the accuracy, okay. So we'll talk more on this accuracy and precision also, don't worry about that. We'll see what do you mean by accuracy, what do you mean by precision, and what is the difference between that also we have to see, okay. If you see the next parameter, that is sensitivity. The sensitivity is defined as the ratio of the change in the output signal to the change in the input signal or the quantity being measured, okay. So basically we can say that the sensitivity is nothing but a ratio of change in output signal to the change in input signal, or a change in output signal per change in the input signal, okay. So suppose if you are applying small change in the input and the instrument is responding as per that very quickly, and the output signal is high, then we can say that the sensitivity is very high, okay. So suppose any instrument is not responding even if you are going to apply the large number of variation in the input, then we can say that that instrument is insensitive, okay. So again, with accuracy also, the sensitivity is again a very important parameter while choosing your instrument, because it must show the smallest change at the input also, okay, because that is very important for us. So the highest sensitivity or higher sensitivity is again the most important parameter which can be considered while choosing the instrument for the measurement. The next is the readability. Readability is defined as the closeness with which the scale of the analog instrument can be read, okay. So here the analog instrument is mentioned here. So the readability is defined as the closeness with which the scale of the analog instrument can be read. So we will see afterwards what do you mean by readability with the help of diagram. Let's concentrate on sensitivity first. See, if the calibration curve is linear, okay, so in this case if you see this is the input and this is the output, okay, and if the calibration curve is linear here as shown, the sensitivity of the instrument is the slope of the calibration curve. So if you see this slope, it is generally the sensitivity of the instrument is the slope of the calibration curve. So what do you mean by calibration? Calibration means what? Measuring our instrument's output for change in input with some standard with some standard quantities or standards. Okay, so calibrating your instrument means what? We are checking our instruments for the correctness, accuracy, sensitivity, and all other things, and just checking our output of this instrument for the correctiveness. We are checking that our instrument is giving the correct output or not. Okay, so that is also the main motto of the calibration. So that's why if you see industry or institutes, there are n number of instruments are available, and calibration of that instrument is needed after some time, after 6 months, 3 months, or 1 year. We must check that our instrument is doing its job correctly or not. Okay, so for that purpose, calibration is always done in industry and in our institutes. Okay, so if you see, I think you may have seen a CRO or a multimeter. Okay, so suppose you purchase one multimeter and CRO, or suppose you have purchased multimeter only, and suppose you are using that multimeter for 6 months or 1 year. Okay, after 1 year we must check the correctiveness of that multimeter. Even if it is showing, it may possible that it is showing some threshold errors or some offset errors, we can say, or it may show you wrong values. Okay, or it may show you wrong deflections. So for that purpose, you must do the calibration of that multimeter after 1 year for the correctiveness of the that instrument. Okay, so if it is showing some error, then we have to reduce that error, we have to repair that instrument, and we have to use that. Okay, so that's why if you purchase any instrument like a CRO, multimeter, DSO, signal generator, okay, the company is giving some time, and companies periodically doing calibration of that instrument, so that your measurement should be error free. Okay, so that's why the calibration is very important. So if the calibration curve is linear as shown in the diagram, the sensitivity of the instrument is slope of the calibration curve. And if the calibration curve is not linear as shown in right diagram, then the sensitivity varies with the input as shown in here. Okay, see the ratio of sensitivity which is given here. It is given as infinitesimal change in output per infinitesimal change in input. Okay, so it is a ratio of this change in output to change in input. Okay, so what do you mean by this word, that is infinitesimal, that is extremely small? Means what? We can say that extremely small or very small change in output for very small change in input, that is nothing but a sensitivity. Okay, so if you see the sensitivity again, this is the relationship between the change in the output reading for a given change in the input. Okay, so this relationship may be linear or non-linear based upon the instrument that you are going to use and the characteristics of that instrument. Okay, but the sensitivity is often known as scale factor or the instrument's magnification, and an instrument with a large sensitivity scale factor will indicate a large movement of indication or indicator for the small input change. Okay, now suppose this change in output per change in input is large, then we can say that the instrument's magnification factor is very good, because for small change it is giving a large variation at the output. Okay, so that's why sometimes it is known as a scale factor also. Okay, so, and it can be adjusted as per the sensitivity of your instrument or your applications also. Okay, so this is all about the sensitivity. So see again, readability in deep. Readability is defined as the ease with which readings may be taken with an instrument. So readability difficulties may often occur due to parallax error when an observer is noting the position of the pointer on a calibrated scale. So readability is nothing but this scales visibility, we can say. So what is the value, what is the value, what is the value? So here this can be easily readable than this one. Okay, so I think you got the idea about this. It's very simple term. Okay, so it is basically what the ease with which readings may be taken with an instrument, and it is generally considered while the observer is doing or noting the position of the pointer. Okay, so this is all about the readability. The next point is precision. Okay, so if you see the precision is defined as the ability of the instrument to reproduce a certain set of readings within a given accuracy. Okay, suppose you are measuring something, and if it is showing the near values, then we can say that it is precise. Okay, and so much variation is not there. Okay, so don't confuse in between precision and accuracy. Your instrument may be precise, but it may not be accurate. Okay, so keep one important thing in your mind is that your instrument must be accurate as well as precise at same time. Okay, so let us see the difference between the precision and accuracy, then you will understand accurately. But if you see the precision, it is a measure of a degree to which successive measurements differs from each other. Okay, so when a set of reading shows precision, the result agree among themselves, so that we can say that it is accurate. But it is not essential that every time the precise instrument is giving you accurate values. Okay, so don't worry about that. We will see the difference between the accurate and precise measurement. Okay, but see this example first. In this example, the precision of a measurement depends on the instrument used to measure it. So it is shown here. The precision of a measurement depends on the instrument that you are going to measure it. Okay, so for example, this is the block that is given to you, and two types of scales are given to you. One is this left side scale, and other is the right side scale. Okay, but if you see this left side scale, it is showing directly from 0, 1, 2. It is not showing in between values. Okay, but if you see the right side scale here from 0 to 1, the in between scales are also printed here, so that we can precisely measure the length of a block. I think now you got the meaning of a precision. Okay, because if you see the right side scale, it is showing the precise value, or more precise measurement is towards this right side. Okay, so we will prefer this right side measurement because it is more precise, because it is showing the in between values also. Okay, so we will not prefer this left side scale. Okay, so I think you got the idea about this precision. Secondly, if you see how big is this beetle, then we will measure with this scale. Okay, generally we can say that it can be in between 1.5 to 1.6, but if you want to tell it is more precisely, you can tell it is a 1.54, because this 4 is very important for us. 0.54. Okay, so either telling it is as a 1.5, it is very better to tell it as a 1.54. Okay, so this is all about the precision. Okay, now suppose one 17 centimeter book is given to you. Okay, and if it is told to you to do the precise measurement, then which will be a better option? Okay, or which will be the precise value rather than better option? Okay, see here, the more precise measurement will be this one. Okay, so we are not talking about accuracy. Okay, please keep in your mind, because your measurements shows the values like this, 15.0, 0.2, 0.3, 0.5, like this. Means what? Who is more precise when measuring the same 17 centimeter book? Then this is more precise because the four values are near to each other, and it is showing a small variation. But if you see here, it is not precise value. Okay, so that's why I am telling you to that more precision may not be give you a more accurate value. No doubt your instrument must be accurate first, and after that it may also be precise. Okay, or it must also be precise. Okay, so this is the basic difference between accuracy and precision. So let us see with our diagram. Okay, so if you see the left diagram, it is having high precision and high accuracy. If you want to hit something here with the 4 arrows, then at this point it is accurate, and all the readings are pointing, or all the actions or all the arrows are pointing here, means it is precise also. Okay, or near to each other. But if you see the right side diagram, as here, if you want to hit here, or if you hit here, then it will be a high accuracy, but it is hitting over here and they are near to each other, then we can say that it is not accurate or low accurate or less accurate, but it is having a high precision because they are hitting towards near value. Okay, so I can explain with more number of example this, so don't worry about that. So if you see the person hit the bull's eye example, then if you see the 3 targets are there which are given here, and with 3 arrows each to shoot. Okay, so if you compare these 3 results, then I can compare like this. Here over the center is our target, and when we hit here, then only we can say it is accurate. And we are having 3 arrows, and if you see first diagram, both are accurate and precise because it is hitting at a center. Okay, similarly, if you see here, the 3 arrows are hitting over here. We can say they are precise, but they are not accurate because they are not hitting at a center. Okay, similarly, if I compare this third one with my target, then I can say that 3 arrows are at a 3 hit point, and there is no any near value to this hit target or accurate value. So that's why I can say that it is neither accurate or nor precise. Now I can now I think that you can define the accuracy and precision very well. Okay, so just refer the book, read all the details about this accuracy and precision, because it is not possible to cover each and every point related to that. I will just give you idea, concept behind that, and after that you have to do the deep study about this. You have to see the more number of examples, but I think this much is sufficient for you. Okay, so this is all about the accuracy and precision difference. Okay, so again I am repeating, it is very good that system is accurate. It is also very good that your system is precise or instrument is precise, but having a precise instrument doesn't mean that your results are accurate. Okay, so we want both things, accuracy and precision. But out of these two, if you want to choose anything, you will definitely choose the accuracy. Okay, because it is very important. But when you require higher accuracy, then precision must also come in the picture. Okay, so this is all about the precision. Now the next characteristics is the resolution. So I think you know the resolution because you are using your mobile camera for taking photos or videos. Okay, then the resolution is nothing but the clarity that you are getting on your picture. Okay, because the more resolution is there, then the more clarity will be there. I think you know about this. So this is defined as the smallest input increment change that gives some small but definite numerical change in the output. I think we have discussed about this ADC in the ADCs and DACs. But why the resolution is very important, because that small change that we are occurring, that is considered here, and we can reconstruct our image here with the help of a higher resolution cameras, we can say. Okay, so this image is having less resolution, this is higher than this one, and this is the highest resolution image, we can say. Okay, so I will not give much time to this resolution because we have seen this. So this is defined as the smallest input increment change that gives some small but definite numerical change in the output, and these small values or dots are very important to get a better image quality in this image only. Okay, so but the resolution is not limited to image only, it is related to different systems and instruments also. Okay, now if you see the threshold, okay, this is a minimum value of the input below which no output can be appeared, which can be called as a threshold of the instrument. Okay, here again I will read, this is a minimum value, or this minimum value of the input below which no output can be appeared as the is known as a threshold value of the instrument. Means what? Suppose here this is the x-axis, which is representing the input of the system or instrument, and this is the y-axis, which is representing the output or output of instrument or system. But we are starting from 0, that you know, in axis we are starting from a 0 towards this right side, suppose, and to this change in the input, it must show the change in the output. Okay, because this is the definition of the instrument or good instrument or the characteristics of a good instrument. But here, while moving from 0 towards the right side, suppose this is a 5 value, okay, 5 unit, suppose to this 0 to 5 I am not getting any value at the output because your instrument is not responding to this. Okay, so that's why in this case I can say that this 5 is the threshold value for this instrument, because below 5 means what, if you change your input from 0 to 1, 1 to 2, 2 to 3, 3 to 4 up to this 5, there will not be any response by the system or instrument. So that's why this can be called as a threshold value. But after 5, your system or instrument will show the linear or proportional change at the output, we can say. So that's why this is called as a threshold. Okay, so it will be very good that this threshold value is minimum. Okay, ideally we want this threshold value as a 0, but practically some threshold value will be there, because practically there are n number of components which are used in instruments, and they are having some errors or threshold values also. So collectively there will be some threshold value while considering any instrument or system. Okay, so this is all about the threshold value. Okay, so I think this much is sufficient for today's lecture, because again there are n number of parameters are remaining and which will not be covered in this lecture. I'm giving you time because please note down this all parameters. Just write it in your own language, make your own notes, just revise it. Okay, because all these parts are theoretical part and it will be very bore situation for you if I continue this lecture for 1 hour. Okay, that's why I'm giving you a time. Okay, and we will revise some concepts, don't worry about this, but I suggest you to revisit all these points and note down these points in your own language. See on internet, see in a book, see the definitions. Okay, so that is very important. Again, important thing is that please see that standards, that are international standards, then primary standards, secondary standards, working standards. Okay, and just again one homework is there for you, that we have seen previously these types of instruments. Okay, so I'm giving you one homework that you have to list down these examples of this deflection type, null type instruments, or all this list that is given over here. Okay, so this is your homework. So you have to note down the examples in front of deflection type instrument, in front of null type instrument, under the analog category, under the digital. Means what, you have to write these instrument types one by one, and under that you have to write down 2 to 3 examples of this instruments, and it will be note for you for exam, or in MCQs also it may be asked for you. So that's why this is the homework to you. Just write down each and every instrument and its examples, 2 to 3 examples, and after doing that, just take a screenshot of that, a photo of that, and upload in assignment section. Okay, please upload that in assignment section. That is very important, because previously you have posted that on general wall, and it will be very difficult for you if I share something on that to search that. Okay, so that's why I suggest you to share on that assignment section in a Microsoft Team. Okay, and if you have any doubts regarding this, then you can ask me. Okay, so in next lecture we will try to complete this static performance characteristics, and we will start dynamic characteristics if it is possible. Okay, so right now this much is sufficient. We have seen the accuracy, then sensitivity, then readability, precision, the difference between this precision and accuracy, and after that we have started with resolution, and we have seen the threshold. Okay, just go through all these points. This chapter is very small, and it will not take much more time to complete this. Okay, but these points are very important as far as the measurement and instrumentation is concerned. Okay, so after the completion of this unit, we will focus more on instruments, types of instruments that we are generally using, like a CRO, DSOs, function generators. Okay, that we will see in upcoming units. Okay, so this much is sufficient for today's lecture. Okay. Okay, so just go through the each and every point, and if you have any doubts you can ask me personally, or you can post on Microsoft Teams. Okay, so we will stop here. Thank you very much. In next lecture we will start with next parameters. Okay, thank you. We will stop here.